Dear students, we have already made the discussion of parallel plate capacitor, what is capacitance, its use and how we use the parallel plate capacitor and all these things, a spherical capacitor, and why parallel plates are essential. These are the things that we have already made the discussion. Now in the next series, in the next class of the discussion of the same electrostatics topic, we are going to, after the discussion of parallel plate capacitor and how parallel plate capacitor behaves as a how a spherical capacitor, when the separation between the two concentric spheres is very small, behave as a parallel plate capacitor. That are the things that we have already seen. Now in the next session we are going to discuss the force between the plates of the capacitor, parallel plate only. What does it mean? It means that the parallel plate capacitor, one plate is positively charged, other plate is negatively charged, and in between the space, due to opposite nature of charge according to the rule of electrostatics, we will feel the force of attraction. So what will be the value of that force of attraction? In actual practice, there is some dielectric, that is insulating medium between the plates of the capacitor. So here we are going to discuss our new topic, that is force on the plate of capacitors. Force on the plates of capacitor. Capacitor means parallel plate capacitor. So see it very carefully. It is very important to understand the meaning and the concept behind it, because the force is very important for you people to understand this concept. So I am drawing a parallel plate capacitor. Suppose here is a parallel capacitor, and in this parallel plate capacitor, one plate is given plus Q charge and another plate is minus Q charge, and the separation between the plates is your D. So what I would like to discuss with you, here in between the plates there will be electric field. This is positive charge, this side is positive charge, and this side is negative charge. So electric field, we have already discussed that in this region electric field is 0, in this region the electric field is 0. Let us call this plate as plate number 1 and let us call this plate as plate number 2. A is the plate area, and D is the separation that you already know. Now the electric field developed between the plates, from the prior knowledge of our discussion of Gauss law, we know that E is basically, due to positive plate the electric field will have this direction, due to negative plate the electric field have this direction. So it is your sigma by 2 epsilon naught plus sigma by 2 epsilon naught, and this is equals to sigma by epsilon naught. What is sigma? Sigma is equals to charge per unit area. So it is sigma by epsilon naught. Now whenever the charge is kept in an electric field, it experiences force. This plate, plate 2, is in the electric field of plate 1 and plate 1 is in the electric field of plate 2. Plate 1 will have also its electric field, but the charge on the plate 1 will not experience force due to the electric field of plate 1. The charge on the plate 2 will not experience force due to electric field of plate 2. Then what will happen? The charge on plate 1 will experience the electric field due to plate 2, and the charge on plate 2 will experience the which will experience the force due to field of plate 1. Now a rough analysis we are trying to show you. That rough analysis is what? Force is equals to charge into electric field. This is the rough analysis. So E is equals to, we have already made the discussion, sigma by epsilon naught, which is due to one portion, this is due to positive plate and this is due to negative plate. So force on plate 2 is equals to QE due to plate 1, force on plate 2 is equals to QE. E due to what? E due to plate 1. Only on any plate the force will not act due to its own electric field. So therefore, what will be the force? F is equals to Q into electric field sigma by 2 epsilon naught. Why 2 epsilon naught? Due to, because for one plate this is the value of electric field. So this is, we can write, this is on negative plate, if we talk, it is minus Q into Q by epsilon naught A. This is your minus Q square by 2 epsilon naught A. Here negative sign means attractive force. Negative sign means attractive force. Attractive force. Negative sign means attractive force. Here the force does not depend upon the separation D. It is important to understand. It is important to understand the force. The force does not depend upon D. What is D? D is the separation between the plates. So this is the thing that we have already met the, you have understood this thing, and see it carefully and repeatedly. Now next thing that I would like to discuss with you, what is the energy stored in the capacitor. So expression for energy stored in the capacitor with the help of same expression that we have seen. So our next topic is energy stored in a capacitor. Our next topic is energy stored in a capacitor using the same expression. If we suppose, let us suppose that the two plates of the capacitor are placed very close to each other. In fact, they are in contact with each other. See, here is the plus charge, here is the minus charge, and net charge is what? Net charge is equals to 0, separation D is equals to 0, and A is the surface area of plates. Now what we do, we apply a force on the, F, we apply a force on the plate to make the separation equal to D without imparting velocity. That means very slowly. What we do, we apply force F so that the plates are separated, so that the plates are separated by distance D without velocity. Without velocity means very slowly. Now in this situation, the applied force must be equal to the attractive force. In order to obtain this condition, in order to obtain this situation, the applied force must be equal to the attractive force between the plates. So we have F applied is equals to Q square by 2 epsilon naught A. And in this situation, when the velocity is 0, then so that kinetic energy is 0. Why kinetic energy is 0? So that energy is not wasted in some other form. So work done, therefore work done by the knowledge of mechanics, by force applied is equals to force into displacement, that is q square by 2 epsilon naught A into T. This work done gets stored in the capacitor in the form of electric energy. This work done gets stored in capacitor in the form of electrical energy. This work done gets stored in the capacitor in the form of electrical energy. Therefore, energy stored, if we represent it by U, then U is equals to W, that is Q square D by 2 epsilon naught A. Now, epsilon naught A by D, this term is basically representing what? It is representing capacitance. So, this is equals to 1 by 2 Q square by C. So, U is equals to 1 by 2 Q square by C. This is the expression for the energy stored in the capacitor. Also Q is equals to CV. Therefore, U is equals to 1 by 2 CV square. This is another form. Also, CV is equals to Q. So, U is equals to 1 by 2 QV. This is also another form of, these are the three forms of energy stored, which is very important, and we have kept the kinetic energy 0. For this we have assumed that F applied is equals to force of attraction between the plates separated, and the plates are separated very slowly. So, this is the expression for the energy stored. It is very useful in solving very small numericals in a very good way, in a confident way. You can solve if you have understanding of these expressions for energy. So, we have seen the expression for the energy stored, and we will see the expression for energy in the capacitor, and we are seeing the popular method found in your book, that is your second method. This method is generally given in the book, and the previous method, which we have already made the discussion, that you have to understand in a better way. So, in this situation, let us suppose that there is a parallel plate capacitor. Two plates are here. One is given the plus Q charge, and on other minus Q charge is there. This is plate number 1. This is plate number 2, and D is the separation between the plates. And A is your plate area. A is the plate area. So, we understand that capacitance of this capacitor, parallel plate capacitor, C is equals to epsilon naught A by D. Initially, there is no charge on the plate of the capacitors. Slowly, in steps, we are starting giving charge from plate 1 to plate 2. Suppose from plate 1 to plate 2 we are giving the charge, we are starting. So, Q charge goes here, and here it becomes minus Q. Similarly, we are starting giving the charge from plate 1 to plate 2. As a result, the potential difference is developed, and the potential difference is given by delta V is equals to Q by C. This is the potential difference. At time t is equals to 0, at time t is equals to 0, charge is equals to 0, and at time t is equals to t, charge is equals to q. On shifting additional charge dq to the positive plate, from here I am shifting additional charge dq. So from additional charge dq, the work done, the small amount of work done dw is equals to v into dq. Why? Because it is potential difference into charge. So total work done, W, so total work done W is equals to integration v dq, and from where the charge initially 0 to maximum charge q. This is your q by c dq from 0 to q, and as a result we are getting W is equals to q square by 2c. This is the expression for the energy stored, this work done, and this energy gets stored in the capacitor. Slowly, by increasing the charge, we increase the potential difference. So this is the expression for the energy stored, and from this you can get that U is equals to half CV square or 1 by 2 QV. So this is the main formula that we have already got. Now the next thing is energy density. Now let us talk about energy density. Now let us talk about energy density. Energy density, what does it mean? It means energy stored per unit volume. We know, suppose that here is the parallel plate capacitor, and the parallel plate capacitor is there, and plus q, charge is on one plate, and minus q, charge is on other plate, and d is the separation between the plates. So just now we have seen that energy E is equals to 1 by 2 CV square, but C is equals to epsilon naught A by D, and potential difference V is equals to E into D. So we can get, therefore E is equals to 1 by 2 epsilon naught A by D, putting the value of C, E square into D square. This is the value of V. V को ठाव में यो लिखे कुछ. So volume of capacitor. What is volume of capacitor? Volume of capacitor is equals to A into D. So energy density, which is energy stored per unit volume, energy density, so energy density that is equals to energy by volume, and it is giving you this. If we represent by U is equals to epsilon naught A E square D by 2 A into D. So this is equals to 1 by 2 epsilon naught E square. Energy density we have got, that is equals to 1 by 2 epsilon naught E square. Now what is important to understand, that C is not present. C is not present. Capacitance is not present. So you should understand that energy density is given by half epsilon naught E square, and this is the expression for the energy density, which does not depend upon the capacitor. Now one more thing that is very important for you to understand, and that will be a very useful thing for you, that what is the energy density of dry air. This data is also very important, and this calculation is also very important for understanding, for a sound understanding, so that you can face the exam confidently. What is that we are trying to discuss? Energy density of dry air. We are trying to discuss energy density of dry air. For this, you should know that for air breakdown electric field, for air breakdown electric field is equals to 3 into 10 to the power 6 volt per meter. This data you have to remember. After this, the air becomes conducting. So energy density so energy density is equals to 1 by 2 epsilon naught E square. What is the value of epsilon naught? 1 by 2 into 8.85 into 10 to the power minus 12 into 3 into 10 to the power 6 whole square, and this will give you 40 joule per meter cube. This is the value of energy density for dry air. We have derived energy density using the concept of capacitors, but it is valid for anywhere which has electric field. Anywhere if there is electric field, we can find the energy density, and for dry air the value is this much. Now we will try to discuss the combination of capacitors. Combination of capacitor. Generally the capacitor is combined in two ways. One is the series combination of capacitor and one is the parallel combination of capacitor. First we will try to discuss the series combination of capacitors. First we will try to discuss the series combination of capacitors. What is that series combination of capacitors? Suppose there are three capacitors I am taking, and these three capacitors are connected with the external source and together with the battery in this way. This is the capacitor C1, this is the capacitor C2, this is the capacitor C3. Now this battery has the voltage V, and what does it mean? Voltage means potential difference. So if this is your higher potential, this is your lower potential. So this side the potential is your V and this side the potential is your 0, so that the potential difference is V. Now from if we switch on it, then charge will start going, and here it will be plus Q, here it will be minus Q, here it will be plus Q, here it will be minus Q, here it will be plus Q, here it will be minus Q. One thing you should understand, for an isolated system the net charge, see here you see this is your isolated section. When this is your isolated section, the net charge should be 0. So here minus Q, here plus Q, and in one section the charge is equal. So what we can see? We can see V1 is equals to Q by C1, V2 is equals to Q by C2, V3 is equals to Q by C3. This potential drop is across the three capacitors. V1 is basically this is your V1 across this is your V2 across second capacitor, and this is your V3. So potential drop V is equals to V1 plus V2 plus V3, that is Q by CEQ. EQ means equivalent capacitance. If equivalent capacitance is that capacitance, if we replace all the three capacitors by a single capacitor, then the result will remain same. So this is your Q by C1 plus Q by C2 plus Q by C3. So what we are getting the result? We are getting the result, therefore 1 by C equivalent. If 3 capacitors are connected in series, then 1 by C equivalent is equals to 1 by C1 plus 1 by C2 plus 1 by C3. This is the expression for the equivalent capacitance of 3 capacitors connected in series. Here you should understand that the total charge given by the battery Q is equals to C equivalent into V, the potential difference of the battery. Now we will try to understand the same thing by an example. I am giving you one example for understanding that. If example I am giving, try to understand this example, that suppose there are 2 capacitors. One capacitor is here and another capacitor is here. There are 2 capacitors. There are 2 capacitors, and here the potential drop is V. Here the potential drop is V, and the graphical representation of this potential drop is given in this way, that here is the potential and here is the capacitance that we are taking. So in this way it is given in this way. Suppose here it is given, the graphical relation is given in this way, and then it is given in this way. Suppose this portion, suppose it is given in this way, and then it this way. Here we are getting potential drop. This is across the capacitor C1, this is across the capacitor C1, and this is across the capacitor C2. So here is capacitance, here is capacitance. When here is the capacitance and this is the potential drop given, then it is being asked, the question is, which one is greater? Which one is greater, C1 or C2? So we have seen, just now we have seen that potential drop is proportional to 1 by capacitance. Just now we have seen that V is equals to Q by C. Q is same as they are connected in series. This C1 and C2 are connected in series. So potential drop is more in C2. What you see here, this length is more. What you are observing, this length is more. So potential drop across, from the figure it is clear, from figure potential drop is more in C2. This distance is more. This distance is from here to here, the distance is more in comparison to here to here. So what we are getting? We are getting that. Therefore C1 is greater than C2, or C2 is less than C1. This is a confusing question. You try to understand it in a proper way. This is the potential drop that we are getting here. This value, if we are getting this value, this is X, and if we are getting this value Y, then Y is greater than X. Y is greater than. So this potential drop is more across C2. So this is the way we can understand this question. Now we should try to understand the parallel combination. Now next heading is our discussion is parallel combination. In parallel combination, what we would like to see? We would like to see in parallel combination that the capacitors, the same 3 capacitors I am taking, they are in this situation connected in some other fashion, as I will tell. Here the three capacitors are there. They are connected in this fashion with an external battery of this nature. Here the charge is different, Q1, Q2, Q3, and this is your C1, this is your C2, this is your C3. So Q1 is equals to C1V, Q2 is equals to C2V, Q3 is equals to C3V, and Q is equals to C equivalent into V. Equivalent capacitance means all the three capacitors are replaced by a single capacitor, but Q is equals to Q1 plus Q2 plus Q3. So C equivalent is equals to C1 plus C2 plus C3. This is the format that we are getting in case of parallel. In parallel combination, each plate of the capacitor is directly connected with source. So potential difference across each capacitor remains the same. Charge on each capacitor is different. Its capacitance is different. At the capacitance is different, so charge is different, but they are directly connected. You see, it is directly connected, it is directly connected, it is directly connected with the source. So this is your parallel combination of. Now after seeing the series and parallel combination of capacitors, we will see few examples based on series and parallel combination of capacitors. So examples based on series and parallel combination. Examples based on combination of capacitors. Now examples based on combination of capacitors. We are trying to understand the examples based on. We will start with a very simple question. First question is in this way, that there is a capacitor which is connected with the other capacitor, and this combination is connected to the other capacitor. Here is point A, here is point B, here is 1 microfarad, this is your 2 microfarad, and this is your 1 microfarad. Find equivalent capacitance between A and B, CAB. Find the equivalent capacitance between A and B. This is our question of discussion. We know that this 1 microfarad and 2 microfarad are in parallel. Therefore, C equivalent of 1 microfarad and 2 microfarad, there is your 3 microfarad, and this 3 microfarad and this 1 microfarad is in parallel. Again 3 microfarad and 1 microfarad are in series. So 1 by C is equals to 1 by C1 plus 1 by C2. So C equivalent is equals to 3 into 1 by 3 plus 1, that is 3 by 4 microfarad. This is your answer. Here, see carefully. 1 by C is equals to 1 by C1 plus 1 by C2. So C is equals to C1 into C2 by C1 plus C2. This is the thing that we have to use in case of two capacitors, so that in quickly we can get the answer in case of two capacitors. Now come to the next example. This example is a very good example, and in this example, before starting this example, I would like to tell you that suppose there are plates. First of all, I am telling you try to understand, there are plates. One plate is this, one plate is this, one plate is this, and one plate is this. If these are the plates, let us suppose the name of this plate is your A, the name of this plate is your B, the name of this plate is your C, and the name of this plate is your D. And in this so example 2 we are taking, and in this we have from here one point is there, and from here one point is there, and we have to find equivalent capacitance. CAC is equals to how much? Here it is given that plate area is A, plate area is A, and plate separation is D. And one more thing is given in this question, that this plate is connected by a wire with this plate. Now in this case, what I would like to tell you here, first we have to know the surfaces, because for capacitor we need two surfaces. Here I am marking the surface. So this is the question, you have to find the equivalent capacitance of this combination. So what are the things that we have to understand here? First we have to understand the capacitors, and then we have to understand the series and parallel combination of the capacitors. So these are the two aspects. So what are the capacitors that we have to understand, and which are connected in series and which are connected in parallel, that we have to understand. That is the main thing to understand in this section. So यो कुरा सबैलाई बुझ्नु पर्छ. Now in order to understand this thing, I am giving the name to the surface. Upper surface 1, lower surface 2, upper surface 3, plate B को lower surface 4, plate C को upper surface 5, plate C को lower surface 6, plate D को upper surface 7, plate 8 को lower surface 8. So we have understood that 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. 8 surfaces are there. How many capacitors are formed? For capacitors we need two surfaces. So first capacitor, here it will be formed. Second capacitor we can get here. This is the second capacitor we are getting. And third capacitor we are getting here. This is the third capacitor we are getting. So in this combination we have understood that there are three capacitors that are formed. The upper surface of this side is of no use, and the lower surface of this side is of no use, because there are no two plates. So 1, 2, 3 capacitors are formed. So we are in a position to understand that 3 capacitors are formed. Here a thing we will have to understand, for plate A there is a single side that is being used, so we will represent plate A by this symbol. This symbol we will represent plate A. Plate A we will represent by this symbol. And plate B, both sides are being used. So plate B, both sides are being used. So we will represent the plate B by this symbol. The two sides of the plates are being used, so we will use in this way. So if two sides are used, we will use this symbol. If single side is used, we will use this symbol. Now what I am going to do, I am going to replace this capacitor by the capacitor symbol. So see here, first plate is this, plate A. Second plate, this is your plate A. Second is your this one, that is plate B, plate B. Third is your plate C. So plate C is also, we will represent by this symbol. Plate C also we will represent by this symbol. And then plate D by this symbol. This is C, this is D. Now try to understand, in D plate only one surface is being used. So I have used this symbol. So I have used this symbol. And in plate A only one surface is used. So we have used this symbol. So this is your second surface. Here, second surface. This is your third surface. Then this is your fourth surface, and this is your fifth surface, and this is your sixth surface, and this is your seventh surface. Try to understand. Good question is there. If you will not pay attention, you will not be able to understanding. So this is your plate A, this is your plate B, this is your plate C, and this is your plate D. B, A. First surface, this eighth surface is of no use, and this first surface is of no use. So we have understood in this way. Now we have to connect plate B. See here, plate B is connected with plate D. Plate B is connected with plate D. So plate B is connected with plate D. Here you see, plate B is connected with plate D. This is your capacitor C1. This is your capacitor C2, and this is your capacitor C3. Now you see, by this combination how we are getting? We are getting in this way that, here you see carefully, first capacitor, now this capacitor can be turned to this capacitor. So the equivalent figure will become in this way, that the capacitor C1 is there, it is connected with C3, and C2 is connected here. This is the equivalent capacitance. Here is the point, here is the point. Here we have the point with C, and here is the point with A. This point, this is the point, this is the point. So this is your C1, this is your C3, this is your C2, and all capacitance if we take as C, then these two are in series. So what we are getting? We are getting C equivalent is equals to 1 by 2C plus 1 by C. 1 by C equivalent is equals to, so this is your 3 by 2C. Hence C equivalent is equals to 2 by 3C. This is the answer. See it carefully. This is not a normal question. This is a very good question. It will enhance your concept and clarity of the series and parallel combination in a very careful way, and very sound understanding and clarity of concept will be there. Now the same question I would like to repeat for your understanding. Think over this question. I am giving you the same question in example 3. In example 3 I am giving you the same question for your homework, that you attempt this question. This is example 3, that is your homework. What is that homework? Homework is same, 4 plates are there. 4 plates are there as in the earlier question. This plate A, B, C, D. Here is the point, it is connected with this one, and here is the point, and here is the point. You have to find C equivalent. C equivalent, that means CBC. CBC is equals to how much? Same condition, each capacitor has the capacitance C, and your answer will be, answer is your 3C by 2. How? That you will try by yourself, and then we will try to understand whether, if you have understood the earlier question, you will certainly be able in solving this question. If you have not understood the earlier question, then you cannot solve this question. So this is for your home. So example 4, the question is in this way. There is a circuit, and the circuit has a section AB. The circuit has a section AB, which I am showing you. Here is the capacitor, here is the battery, here is the another capacitor, and this point is B and this point is A. So this is the circuit has the section AB. Here is the capacitor C1, here is the capacitor C2. Its value is your 1 microfarad, its value is your 2 microfarad, and this battery has the voltage E is equals to 10 volt, and we have, it is also given that this point is A, this point is B. It is also given VA minus VB is equals to 5 volt, and the question says that what is the voltage drop across the capacitor C1, how much, and what is the voltage drop across capacitor C2. This is the question. The circuit element is the given, and you have to find the voltage drop across the capacitor C1 and the voltage drop across the capacitor C2. The C1 has the capacitance of 1 microfarad, the C2 has the capacitance of 2 microfarad, and the battery has the voltage of 10 volt. Now here you have to understand that something you should understand in very proper way, that how to solve this question. In order to solve this question, I am considering a point here, that is your X, and I am considering a point here, that is your Y. So this battery, this is plus and this is minus. What is the difference between a battery and a capacitor? Capacitor has also charge, battery has also charge, but the capacitor all energy is given at a time, whereas the battery discharges the electrical energy slowly. For example, in a bucket of water, if whole water is given at a time, that behaves as a capacitor, but if by using a tap you are taking out the water slowly, then that is the purpose of the battery. So we have considered the 2 points X and Y, and then we will try to find the value. Now this is one branch is there, so charge will remain same. Here the charge will remain same. If this is plus Q, then this will be the plus, this will be the minus, and here it will be the plus, it will be the minus. So here also the charge will remain Q only. Why it will remain Q? Because in a single branch same charge is there, this side plus, this side minus. Now I am trying to, in single branch the charge remains the same. Now this is plus, this is see, in the battery if I write in this way, it means this is at higher potential and this is at lower potential. So here what we see, that I have considered this as plus and this as minus. So we can say, we can write the potential difference. We can write the potential difference VA minus Vx is equals to potential drop across the capacitor C1 Q by C1. This is the first we can write. How? Higher potential minus lower potential is equals to potential drop. Similarly, this is higher potential, this is lower, this is actually lower potential, this is higher potential. So we can write Vx minus Vy. Now try to understand. This is lower potential, this is higher potential. So it will be low minus high is negative. So I am writing minus E1, that is the voltage, minus E, and Vy minus Vb, and Vy minus Vb is equals to how much? Again potential drop. Vy is higher potential, Vb is lower because this is plus, and so it is your Q by C2. If we add all the three, we are adding, by adding, what we can write? We can write this Vx will cancel, Vy will cancel. We can get Va minus Vb is equals to Q1 by C1 plus Q2 by C2 minus 10. Q1 is equals to Q2. One branch is there, so Q1 is equals to Q2 is equals to Q. So we can get Va minus Vb is equals to Q1 by C1 plus 1 by C2, that is giving you Q C1 plus C2 by C1 into C2. So what we are getting? So finally, therefore, Q is equals to Q minus 10. We are missing minus 10. Minus 10. Q is equals to Q. Don't say Q. Va minus Vb is what? According to question, Va minus Vb is your 5. So 5 plus 10, that is your 15 is equals to Q times C1 plus C2 by C1 into C2. So Q is equals to how much? Q is equals to 15 into C1 C2. C1 C2 is how much? C1 is your 1 microfarad into 2 microfarad by C1 plus C2 is how much? C1 plus C2 is your 3 microfarad. So this will cancel and you are getting, this 5 ja, this is not cancelling, this is 2, this 3 5 ja, 5 2 ja, 10 microcoulomb. 10 microcoulomb is the value of Q. So we are getting Q is equals to 10 microcoulomb. This is the charge we are getting. Now the problem becomes simpler because Vc1 is equals to Q by C1, that is 10 microcoulomb by C1 is 1 microfarad, that is your 10 volt. This is first answer. And V potential drop across the capacitor C2 is equals to Q by C2, that is 10 microcoulomb by 2 microfarad, that is your 5 volt. This is your answer. This question is very important to understand in a concept building process, that if a battery is here of 10 volt, what does it mean? It means that here the potential, if we take 10, then here the potential we will have to take 0 volt. So this is high potential, this is low potential. So potential difference is equals to this EMF of battery, and that is your 10 minus 0, that is 10 volt. This is the thing that you have to understand in a very careful way. So this is the way. In battery there is always plus sign is higher potential, minus sign is lower potential, and this way we are going to explain it. On the similar concept, I am giving the last question. On the similar concept, I am trying to give you the last question, that is the 5th question on the similar concept. And what is that question? That question is in this way. Here is the capacitor and here is the battery. Here is the another capacitor and here is the again battery. This is, there are two battery. This battery EMF E1 12 volt, this battery E2 that is 6 volt, and here the capacitance C1 is equals to 1 microfarad and C2 is equals to 2 microfarad. Now what we can see here, that, and what you have to find, you have to find again the same question, voltage drop VC1 is equals to question mark and VC2 is equals to question mark. This is the same question that we are trying to understand, that what is the voltage drop across the capacitor C1 and what is the voltage drop across the capacitor C2. Again what you will observe, that in this case this branch is the single branch. So single branch concept is what? So charge will remain same. This battery is stronger, so I am taking here the minus Q charge. I am taking here the minus Q charge, and here it is the plus Q, and similarly here plus Q and here minus Q. Why? Because the single branch is there, so charge will remain the same. Single branch, single branch, single branch. So Q1 is equals to Q2 is equals to Q, say. Now we will apply the same concept of potential difference, that if we consider this point as the A point, this point as the B point, this point as the C point, and this point as the D point, then try to understand that how I am writing the equation. Here we can write, here this point is at higher potential because this is plus, this is minus, so VA minus VB is equals to E1, that is 12 volt. Then VB minus VC is equals to, now you see this is lower potential and this is higher potential. This one is lower potential and this one is at higher potential, so it is your minus Q by C1. Similarly VC minus VD is equals to minus 6 volt, because this C is at higher potential and D is at lower potential. This battery is stronger, so that is equals to minus 6 volt, that is your E2. And finally VD minus VA is equals to minus Q by C2. Adding we get what we get? We get 0 is equals to E1 minus Q1 by C1 minus Q2 by C2 minus E2. So therefore E1 minus E2 is equals to Q 1 by C1 plus 1 by C2. This is giving us Q is equals to E1 minus E2 by C1 plus C2 into C1 into C2. So therefore Q is equals to E1 is how much? 12 minus 6 by C1 C2 is how much? 213. 2 plus 1 3 into 2 into 1 2 into 1. That is your 2 into 1. That is your 4 microcoulomb. When we have got 4 microcoulomb, Vc1 is how much? Vc1 is equals to Q by C1, that is 4 by 1, that is 4 volt. This is your first answer. And Vc2 is equals to Q by C2, that is 4 by 2 is equals to 2 volt. In this way, what we have understood, that this type of questions are very important for you people to understand and build up your concept and build up your concept, so that you can understand it in a better way and you can face the examination confidently. So with this, I am ending the session, this one, and then in the next class we will discuss some other matter.